Thank you, Professor Bates, for organizing this meeting. Thank you, gave my chance meet our friend in here. My title is Class Group and Relation Quadratic Extension. It's recent my paper in Arithmetics 2011. First, introduce this paper is Genesis theory. Gauss invite quadratic number theory E. We know is two rank natural class group equals to t minus 1. T is the number of primes which is ramified in the E. Also is rather gave the methods to compute for rank that D equals to P1 star PT star be the discriminant of E. We also is using this matrix. This matrix is called radial matrix. Also is coefficient is round symbol, Jacobi symbol, canonical symbol. Also we can matrix over is F2. We represent one is by 0. Also is minus 1 by 1. We can use this matrix compute quadratic field for rank t minus 1 minus rank RE. Question is, in general case, if E is P extension of F, how to compute the P rank of class group of E? We know the reset for relation P extension E of F class gave a method to compute P0 subgroup of class group CE. Support that E over F is a relative quadratic extension and the class number of F is order. I gave a formula. CE for rank equals to M minus 1 rank REF, where REF is the matrix of no-capital symbols with the coefficients in F2. Just this formula is like rather formula. Also, support EF is relative P's function field extension by Hu and Jun. Generated the red matrix this formula is the function field. Also, is question is we need is order is represents even. In general case, this formula I cannot give, but we can in some special case we also give this formula. This is my talk. Gave this formula. My talk is main theory. Support R2CF equals to S. For rank CF equals to 0. And to select subgroup of CE is elementary. Suppose the S consistent of all infinite primes and infinite and finite plus P1 PS of F, which lambda in E, and this ideal class group CS F has order, then R2 CE equals to M minus 1 minus R2 in the formula, or also give R4 CE equals to this formula, where M is the number of all the primes of F ramified in F. REF plus is the matrix with coefficients local have the symbols in F2. REF just like a Reg matrix. The Reg matrix is a round symbol. This matrix is local symbol. Just we gave this talk is given this reset. We know is about the class group. We know the reset that E is biquadratic field with class group is we see is Klein for group. Then E of Q has three intermediate fields. U1, U2, U3, UE is unit groups of the F1, F2, F3, E respectively. Quite careful formula. Maybe it's 50 years. This formula, but this is UE is large field unit group. This is small field unit group product. This number is difficult to compute. Same use the correct formula to compute this Fourier of class group by quadratic field. Also, that E equals to F squared D is the relative quadratic extension of F. Class group C2 equals to Galois group 1 sigma action on the class group CE, and there is the exact sequence where MEV is a subgroup of ambiguous ideal classes. There is the Reynolds formula. We can see it's such long cyclotomic fields. Okay, ambiguous class number is equals to HF to this formula, where M is the number for all the primes of F ramified in F. If F large ones, where there is the exact sequence, is exact sequence. We're using this exact sequence in this paper. Also, supported class group is order. We have R2 CE equals to R2 ambiguous EF, and minus 1 R2 CF is the formula. And this paper, this talk is we say this class group is not order. So this formula is FS. So we can generally use the formula. Our given notation is EF squared D is the relative quadratic extension of F, or F or E is a ring. UF UE is a unit group. CF CE is class group. HF HE is class number. P is class of ideal. N is simple, is field normal map from the E to F. Nx equals to is normal of X belongs to E to F. A2 is two slow subgroup. Right and left. Left is all the last two. This is two rank. M is all the primes of F ramified in E. N denote number of finite primes of F and that ramify in E. Now we use given is exact hexagon. This is Koch-Ham ranking is given is formula R2 R0 EF H1 C2 CE. This is formula. This is just like Ham-Brown 6 x game. This formula. This formula we can use this formula as computer Forlong. Just use the Forlong. Also the D1 D0 we can also give connect that E equals to F squares delta Galois EF equals to 1 sigma C2, and UE is unite group. H0 C2 CE H0 cohomology is Tet cohomology is just Tet cohomology. Just write CE stable normal CE just stable ambiguous. This is H1 H0 to Tet cohomology. And this is A class is maps to U class. U class is just like UE stable is just UF normal UE. Just this is the class group. C A class A inverse class V V class. This is Tet cohomology. Also H1 also is H1 is Tet cohomology, is cycle modular cocycle. We also is in this map. So we can get this exact hexagon. Also this is relation 0 R0 R1 is deformation. This deformation we can also this is Koch-Ham ranking support this formula. Okay, next we introduce my main reset. First, we recall main reset is this thing is assume is R2 CF equals to S, R4 is CE equals to 0, that SF equals to P1 PS, PIOE is equals to P square, PI square. PI is ideal class group. Ideal is ideal. P1 is P1 is F class, F ideal. P1 this is E ideal. This relation. So you also is the S ideal class group is CSF equals to CE modulo H. S equals to SF include infinite price has order. Without lossy generator that H equals to H1 HS equals CF square. Without loss generator, with pi square equals to x1 OE. Xi belongs to Fi. And CE square H 等于 P1 times PS. This is the reference we replace the P1 with the PIH, where H equals to CE, and 2S is the order. 好， these things when this paper is keyword is these things. This thing is we need use this exact sequence 1 minus 1 equals to kernel n equals CE. This is two slow subgroup, and also CF two slow group. This CF is two elemental group. So this is this we will is divide three part lifting CE K1 plus K times K2 times K3. How to lifting? This is my paper is K where? We can lifting is H1, H2, H1, H2, H3. How we can lifting CF2 H into CE? Their exact sequence. We use this exact sequence. This is map is normal. CE two slow group. CF is two slow group. We lifting. We should is divide three part CF. How to divide three part lemma? There is direct sums of two elemental group. H equals to H1 times H2 times H3. We also H is elemental group, so we can give these directions. Where for each one is not equals one, so the P belongs to H, with P square is the XOF. If P belongs to H1, if X UE interject NOE no empty. This is put in H1. This is keyword is just put H1. This is put H2. Is just is OE normal no empty. This is non-empty is put H2. Also this is empty is put H3. This is K-aware. Also you need this is where we can lifting H1, H2, H3 into CE to slow group. Lemma that K1 Ki is K1. I just say right. Okay. K1. I said this is also is for example this is P OE equals to p square. This is k1 times k2 times k3, just lifting. Okay, is lifting k1. Also lemma, suppose P belongs to CF to the group P square equals to XOE, POE equals to P square. Then the P belongs to H1 if and only if P is an element of 2 order in the CE. Also, is P belongs to H2 if and only if P is element of order 4 in CE. And there is an element B belongs to CE of order 2 such that B normal equals to P. 4 is P belongs to H3 if and only if P is the element of order 4 in the CE, and there is not any element B belongs to CE of order 2 such that B equals to maps to B. This lemma is the K. Okay, when we use the lemma, we can get this CE square equals to H1, H2, H3. This is exact sequence. Just is algebra things is lifting. This exact sequence. This H1 lifting is 2 elements, so we can is K1. Also is H2. We can use this 2 element normal, so we can also use K plus just is B, just like B. Substitute is K2. Also is not substitute this is K. This is K well. So we can use lifting. We can use where order paper is 209. Just Professor Bai-Jun function field also can do these things, and this is K well. So we can get the series support that CF2 equals to S, and of epsilon CF equals to 0, and then the 2 slow subgroup of CE is elementary. Support S is consists of infinite price and finite price P1 PS of F, which nominalified in E, and S ideal class group CE has odd. Then R2 CE equals to S plus n minus 1 minus log 2 CO CFS. CFS is S ideal class group, and no. CFS is S is unit group. Sorry, it is unit group. S unit group. UFS inject NE is this formula. Also, we can also compute S3 equals to log 2 UFS, UFS interject CE. This minus this formula. This formula. We can schedule proof. We have we know this formula is Sergilon's box. We support this formula. Ambiguous is EF HF 2 minus 1 UF interject NE. Then K equals to K1 times K2 times K3. Sorry, K3 in subgroup subgroups M equals EF2, then there is exact sequence. This is exact sequence where M is two-element subgroup, and hence we have these directions. These directions we can get ambiguous class group and 2 rank equals to M minus 1 plus S1 log this number. We can also use this I2 K1 plus 2 kernel N is K1 is times this subgroup. Hence, R2's CE equals to this formula. We can also this exact sequence. When you sense by time product of F2, we have exact sequence. This exact sequence we use above lemma. We get exact sequence. Then we got R2 CE equals to this price. We can use this formula. We put in. We get this US is S unit group. We can get this formula. This formula just like my older paper is 209 is just to get it. So my paper is the keyword is my two element subgroup lifting into CE. We can get this reset, this formula. Also we can also get this 4 rank support that R2 CF equals to S and R4 is CF equals to 0. Then two slow subgroup CE is elementary. Suppose that S consists of all infinite price and finite price P1, PS of F, which is ramified in F, and S is ideal class group. CSF has order order, and then we can get this formula. Where is M is the number for all the price of F ramified in F, i.e. F plus is the matrix of with coefficients of local help symbol F2. So let's review. Let's see is C REF price. We can also see this price IF. This is XX1, XX2, XSN. Just is H3. This is because this is P square is then xi OF. This xi, this xi, subdot xsi is just H3. U1, UT just is H2 subdot U1, U2. UT plus 1 UL just the CU's UF is just this U1 times UT T times UT plus 1 and UL. This is where the UI belongs to NE, where the UI is not NE, so UI is put in. Well, D is just is real quadratic field is D. E equals to F squares D. To D. Or is P1 when it's Pn plus the K is just this is EF FE. All is Ramified price. We can use computer no capital symbol, so we can get this formula. This formula is just like a large matrix. Where large matrix is had a symbol, where original large matrix just is the long symbol. This is very near. Now, all the proof is very technical, so I don't support. So we also can give this example. For example, F equals to Q square minus 21, E equals to F square 5 times 11 13. We can also compute this class group is 2 rank 3 4 rank 1 of 203 3 2 now this as ramified we can kill these 2, so we can also compute this CE is 4. We can use this formula, we can get CE is 3. Also, this biquadratic field. This also we can compute this formula. This formula we can also this CE is 2 rank 3. 4 rank is equals to 2. Using this our formula. Okay. My talk is stopped here. Thank you for your attention.